Hi, and welcome to an introduction to row integration by parts. Integration by parts is basically the product rule for integrals, and the formula it gives us is the integral of an f times a g is equal to f times the integral of g minus the integral of the derivative of f times the integral of g. RIP, or row integration by parts, is basically the tabular method for integration by parts with an emphasis on the rows. Each row represents an integral, and we proceed one row at a time. In the table, we start with plus minus signs, functions to be differentiated, functions to be integrated, and a fourth column representing integrals of the product of the information in a given row. We start with the plus sign to indicate a positive 1, choose an f to differentiate, a g to integrate, and take the product of 1 times f times g, and integrate that product. Note that this top row represents the original integral. The next row, we alternate with the minus sign indicating a negative 1, differentiate f, integrate g, and take the product of negative 1 times the derivative of f times the integral of g, and integrate that product. So notice that we have all the information we need for integration by parts, then we just got to gather the terms. To do that, we take 1 times f, go down a row, multiply by the integral of g, that gives us the first pair of terms right here. And then to get the integral, of course, that's represented in the second row. That's basically it. If we need to, notice that we could iterate integration by parts, or we could deal with this integral in some different way. But let's see how some different examples might play out. As a first example of RIP, let's take a look at the integral of x times natural log of x. So we start off with our table. Always start with the plus sign indicating positive 1. In this case, I'm going to differentiate natural log, and that leaves x to be integrated. Notice that the product of 1 times natural log times x gives us the original integrand. So the top row represents the original integral. In the next row, we alternate and get a minus sign representing a negative 1, differentiate, integrate, and then take the product of negative 1 times 1 over x times x squared over 2 and integrate that product. The integral we get is negative x squared over 4 plus a constant. So we're done. We've evaluated this new integral from integration by parts. All we've got to do is go back and gather the terms. So to get the integral of x times natural log of x, we take 1 times natural log, go down a row, pick up the x squared over 2, and then x squared over 2 times natural log of x is our first term. The next term basically just comes from the integral in the bottom row. And that's it. Let's revisit example 1. This time we're going to intentionally make a mistake, sort of. We're going to make a bad choice of functions to be differentiated and integrated and see what happens. Alright, so we start off with our 4 columns. Always start with the plus sign to indicate a positive 1. In this case, I'm going to switch it up and choose to differentiate x, leaving natural log to be integrated, and that's basically going to be the problem. Right, but notice that we still have the top row representing the original integral, in the sense of we have 1 times x times natural log, and when we integrate it, we have the original. In the next row, well, we get alternating plus minus signs. We have a minus sign for a negative 1. Differentiate x to get 1, and then, well, if you don't know how to integrate natural log, that's a problem. And in fact, it requires integration by parts. You get x times natural log of x minus x, but basically stop and try a different procedure, like we did in the first attempt with example 1. Note that we can easily iterate integration by parts. That is, even though we start with an integral and end up with a new one, we could replace this new integral with the formula for integration by parts as well. So what we would get if we continued to differentiate f's and integrate g's is this formula right here. Right? And then, well, maybe we want to keep going. Maybe we think that applying integration by parts again will lead to something slightly better. But when do we stop? Well, notice that it completely depends on the last integral that we're generating here. So we're alternating negative, positive, negative signs in front of these new integrals. But ultimately, these new integrals tell us if we're doing something well, or if we're wasting our time and spinning our wheels, like in that revisited example 1. So let's look at an example where we should definitely iterate integration by parts and see how looking at the rows can tell us how to stop. Okay, for example 2 of RIP, or row integration by parts, we're going to integrate t to the 4th times e to the t. So we start with our 4 columns. Okay. Top row is going to begin with a plus sign to indicate a positive 1. I'm going to choose to differentiate t to the 4th and integrate e to the t. Okay. So notice that the top row does represent the original integral, and I don't even need to write that down, right? Because I clearly have the integrand represented here if I take the product of the 1 times the t to the 4th times e to the t. Going through the procedure, alternate plus minus signs. I get a negative 1 represented by a minus sign here, 4t cubed and e to the t, and consider the product and its integral. We had to investigate what this gives us. Well, notice that the power of t is now 3. It went down from t to the 4th to t cubed. So we shouldn't stop just yet. We could keep going because eventually we will exhaust these powers of t. So the next row down, we alternate plus minus signs, get a plus sign for a positive 1, 12t squared e to the t, keep going. Alternate to get a negative sign, a negative 1, so 24t e to the t. And finally, I'm going to stop at positive 1 times 24 times e to the t because its integral is something that we can handle. Of course, it's just 24 e to the t plus a constant, so we're done. At least we're done building the table, right? Now we got to go back and gather all the terms, but that's piece of cake. The integral of t to the 4th e to the t, or I should say an antiderivative of t to the 4th e to the t, is obtained by taking 1 times t to the 4th e to the t, and then a negative 1, 4t cubed e to the t, and so on and so forth. To get the last term, we take the result of the integral from the bottom row and include a constant. And that's it. So, please subscribe, check out the playlist, and learn to master integration by parts.